Hi, my name is Jonathan and my teammate Yavuz. We will together introduce two different printing methods in this group presentation. Thermography, also known as raised ink printing, is a post-press finish that creates a subtle tactile relief. A finely milled polymer powder clings to wet, slow-drying ink and then passes through a high-heat oven, fusing into a glossy, raised film, delivering an elegant embossed look without the cost of engraving plates. And how it works is there will be 4 key steps into this method. The first one would be offset printing with slow dry ink, and the inks are formulated to stay tacky. And then the second step would be powder application. The sheets travel under a shower of thermographic resin powder, which adheres only to the wet ink. And then the third step would be excess removal. It's a built-in vacuum that reclaims stray powder for reuse and keeps the sheet clean. And finally, thermal fusion. Sheet passes through an infrared oven at 500 to 700 degrees Celsius for 2 to 3 seconds, melting powder into a smooth, raised surface. But what is it used for? Thermography is ideal for premium business stationeries like cards, letterheads, and then invitations for weddings and galas, and then greeting cards and gift wraps, certificates and diplomas as an engraving alternative, or high-end labels and packaging. The typical relief heights are about 0.1 to 0.3 millimeters, offering a noticeable yet tasteful effect. But what are the strengths of this method? The first one would be cost efficient because they would not need to buy more engraving dies. And for the second one would be a quick turnaround where the powdering and fusing only add minutes to the process. And the third one would be the flexibility where it works on most coated and uncoated stocks. And then the weakness of this method that it might cause solid fills that can puddle or texture unevenly on the design. And the second one would be the detail constraints where very fine lines under 0.5 points may not powder cleanly. And the third one would be the environmental impact, where the powder residues in high heat ovens may consume a lot of energy and generate waste. And then how would we prepare this method? The first step would be selecting and defining a spot color and name it as thermo for all raised elements. And then we would need to keep the elements vector-based with the strokes no thinner than 0.5 points. And then we need to set thermo objects to overprint to avoid color knockouts. And finally, we would have to export them as PDF, preserving spot color separations for the raster image processor. And then the concerns of this printing method is that the first one, like I said, would be the environmental impact of this, because the powder in the oven would contribute to a lot of CO2 emissions. And the second concern would be the economic considerations, where if we are looking at scalability and if we have beyond 10,000 units, other methods like blind embossing may become more financially friendly. And the third one would be the health and safety, where the dust control could be a big concern because of the airborne resin particles, and the powder may damage the lungs of the workers. And as for the maintenance for this printing method, is that we need to do an oven calibration, because we need to check the belt speed and heat output for more uniform embossing results. And the second one would be the powder systems, where we need to clean hoppers, shakers, and vacuums a lot of to prevent clogs and contamination in the printing process. And then for alternatives, we can consider blind embossing that would create a similar raised effect via die press without ink. Or the second one would be foil stamping, where we can apply metallic or colored foil with heated dyes. And We can also try digital embossing because we don't have any dyes used there, and it's also powder-free embossing on digital presses. And finally, we have spot UV coating, where we can selectively varnish for gloss or slight relief for the finish.
Lenticular printing is a printing technique which, when you view from various perspectives, produces pictures that appear to have depth, movement, or transformation. The lenticular lens, a sheet of plastic composed of small parallel lenses, is combined with carefully prepared pictures to create this look. Here is a great example of when lenticular printing can be used to enhance branded design. The Adidas is All In campaign made in the 2010s demonstrates movement through the use of lenticular printing, mirroring the brand's connection to sports. They are able to display various sports and athletes in one area through the use of lenticular printing, something a regular print could not accomplish without being divided. Using lenticular printing in the 2010s makes Adidas a progressive company that welcomes change as well. The first step in the production of lenticular printing is dividing several images into small sections interlaced together in a predetermined order. Then a lenticular lens is mounted over the interlaced image. Each lens reflects light in a way that allows a portion of the image to be seen from a certain perspective. Lenticular printing is commonly used in the fields of advertising and marketing, packaging, signage, art and photography, collectibles and souvenirs by designers for producing unique products that grabs customers' attention and engagement. The key strengths of lenticular printing are being eye-catching due to visual effects, being interactive by making the consumer engage with the product as they change angles, and creating a memorable experience through these things, something regular prints cannot provide. Moving on to the weaknesses, lenticular printing is more costly than other printing techniques because of the specific tools and supplies needed. Its effectiveness may be reduced sometimes based on the viewer's angle, and it is a challenging process that requires meticulous preparation and experienced designers to get optimal results. To prepare it, you first need to pick your method of choice. This could be flip lenticular, 3D lenticular, or 4D lenticular, which is a combination of both. Then you need to determine the distance for viewing. And finally, you need to prepare the file in Photoshop, building the graphics horizontally or vertically based on the choice of visual effect. The main concerns about lenticular printing are visual fatigue, as the visual effects may cause it when looked at for long periods of time. Environmental concerns because of the PETG plastic which lenticular lenses are made of. It can cause serious environmental issues if it is not recycled properly, as it is made of non-biodegradable material. And finally, difficult recycling. Curbside bins and various recycling facilities in Australia do not accept PETG plastics, which are categorized as Type 7 other plastic under the Resin Identifier Code. Recycling them is a complex and costly process due to materials and contamination. The things you need to do to maintain lenticular printing are lenticular lens maintenance. For optimal results, use a microfiber cloth and anti-static gloves to remove any dust or smudges from the lens surface before printing. Then there is regular printer maintenance, which is essential for any kind of printing. Make sure to clean the print head, check calibration and alignment, and replace the ink. The possible alternatives to lenticular printing would be holograms, which provide a real 3D experience without the need for printing, flip animation, which provide visual effects at a low price through cars or books, moire animation, which uses overlay grids to create the appearance of motion, and digital displays, which provides visual effects through an electronic screen and power instead of print.